Okay, so in last lecture, I guess we have seen Fourier transform, right? Can you just tell me the definition of Fourier transform? What the Fourier transform does? As its name itself indicates, it transforms one domain into another. There is a function which is in X domain is converted to S domain, right? And the definition for the same is we denote it as f of S, function of some S, and is defined as 1 upon
root 2 pi
root 2 pi, correct? Integration from
minus infinity
minus infinity to infinity, correct?
f
F
of
of
x
X
e raised to isx dx.
e raised to isx dx.
X.
Function is in X, so integration is with respect to X. Good. We have seen this. Now we'll go with inverse. Give the heading. Inverse Fourier transform. So what the inverse Fourier transform's role will be? Its role is to convert the domain S back to the domain X. Right. As its name says, it reverses the process, it inverts the process. That is, whatever we have converted in S, we have to convert back into X. And the definition for the same is, as we are converting it back, so here we'll get f of X. And is defined as 1 upon root 2 pi integration minus infinity to infinity, and these roles will change, will reverse the role. So here is f of X and there will be f of S, right? E raised to minus isx. For transform it is plus, and for inverse transform it is minus. And with respect to what you say? What should be with respect to?
ds.
S, right? As the function is of variable S, so it should be with respect to S. So converting back to the original domain X, we should always integrate with respect to S. It was originally in S, right? So to take it back, you should integrate with S. And in Fourier transform, function is in X, so you should always integrate with X. Write the definition properly. Can I go to questions?
Yes, ma'am.
Yeah? Right. Write the question. Find the Fourier transform of. Find the Fourier transform of f of X is equal to 1 when mod X is less than K, and 0 when mod X is greater than K, and hence evaluate first integration from minus infinity to infinity sin sk cos sx upon s ds. Second, integration from 0 to infinity sin ks upon s ds. And third is integration 0 to infinity sin s upon s ds. Okay, see the question first. Given is a function f of x, and you have asked to find the Fourier transform of it. So you will first read it very carefully with the Fourier transform. I always tell you this. Check very properly the word, whether it is series, whether it is integral or transform, and what? Sine, cosine, or just the Fourier. So it is the Fourier transform, right? So we should first write the definition of Fourier transform. Can you tell me the definition? Formula?
1 root pi
F of
x
S, right? 1 upon root 2 pi, right?
integration minus infinity to plus infinity f of s e raised to minus ix ds.
No. F of X.
E
We
raised
are
to
writing transform itself, not the inverse. F of X e raised to
isx
Sx dx.
dx.
For the straightforward Fourier transform, there is plus, and for inverse, there is minus. So if question is not inverse, question is Fourier transform, and given is a function in x, right? So we should use the Fourier transform formula. Good. This is what the definition is, and then we have to solve it. For that, you should write the function f of x. F of x is this, is defined on mod x is less than k. What it means? What is mod x is less than k means?
Minus k is less than x is less than
Very
k.
good. Minus k is less than x is less than k. So in this interval where x are greater than k, the value of the function is 0. So no need, madam. So no need to consider this 0, right? So function is having value 1 on this interval. So what the value of the function and where it is? So it becomes 1 upon root 2 pi. What is the integration limit?
Minus k to k.
Minus k to k.
Right, minus k to k. And what is the function on minus k to k?
1.
1. So 1 into e raised to isx dx. Now you will say, as it is minus k to k, you should check for even odd, right? We always do that. But what about this? If we replace x by minus x, will it be like function itself? No. E raised to isx, no. Whether it will be minus of f of x? No.
No.
So it is neither even nor odd. Am I right?
Yes.
Yes.
That's why we are directly integrating it. What is the integration of e? Is e itself. E raised to isx upon derivative of this with respect to x. What is the derivative?
Is.
Is, correct. And that is from minus k to k. Chalo. So this is I'll take out 1 upon root 2 pi. As constant, it can come out is. Upper limit, we are placing over what? S or x?
X.
X, right? As it is with respect to x. So e raised to is k minus e raised to x is now minus k. So it is minus is k. Right? This is also okay. But we have one formula. What is that formula? E raised to I theta minus e raised to minus I theta upon something is sine theta. So what is upon?
2i.
Y. Very good. And what is the cos theta's formula? Plus e raised to
E raised to
minus
I.
I theta upon
2.
only. Correct. So if upon, but if negative is there, we'll need upon 2i. And if positive is there, we'll need upon 2 for the formula. So as negative, we'll need 2i. So we'll divide by 2i and we'll multiply by 2i. Okay. Here I get cancelled, right? 2 is nothing but root 2 into root 2. This 2 upon root 2 pi, that is root 2 into root pi. And what is this? S
Sin
is there. S is there. S is there. Right. S. I cancel. S is there. Huh. What is this?
Sin sk.
Sin sk. Correct. E raised to I theta. Theta is sk. Minus e raised to minus I theta upon 2i. So it is sine of sk. A root 2 get cancelled. So it is root 2 by root pi into sine ks or sk. Sine sk upon s is your f of s. Is everything in s? There is
Yes.
no x, right? So this is your required f of s, required Fourier transform. But it will define for all s except what? This will define for all s except what?
X.
No. This value defines it will exist for all s except one s, one value of s.
S equal to 0.
Correct. If s is equal to 0, the denominator is getting 0 and anything upon 0 that will go to infinity. or if you put 0 on both the places, that is 0 by 0 form, and that is indeterminate, right? So for s is equal to, it will exist if, so let me just write the answer. F of s is equal to root 2 by root pi sine ks upon s, but s should not be equal to 0, because if s is 0, that will not exist. So we'll have to solve it separately for s is equal to 0, because this is the value everywhere except at s is 0. So for s is 0, we should check the value. If you will not check, that is also okay. This is your required Fourier transform. But if you understand that this is not giving you value at this as 0, so you should check it for that number. So f for s is 0, f of s is equal to, here it is. In this equation 1, we can put now s is equal to 0. So if s is 0, e raised to 0. What is e raised to 0?
1.
1. That is 1 upon root 2 pi integration f of x. F of x depends on minus k to k, and the value is 1 into e raised to 0, that is 1 dx. That is 1 upon root 2 pi integration of 1 dx. What is the integration? Integration dx is x from minus k to k. So it is 1 upon root 2 pi upper limit k minus of minus k, that is plus k. So it is 2k upon root 2 pi. Right? So if s is 0, the value of this is this. That is, if you want, you can simplify further. Root 2 root pi k, root 2 cancel, and it is root 2 upon root pi k. For s is equal to 0. Okay, so we got the value of Fourier transform. Now there are some sub questions. You can check. Whatever we have solved, the Fourier transform, hence evaluate means use that Fourier transform and solve for this. Find the values of this. Take a quick look on all those integrations. Okay, and it is with respect to s. And when it is with respect to s, when it is with respect to s, whenever we are taking its inverse Fourier transform. So yes, we have to take the inverse Fourier transform of the given thing. Do you understand from this? As there is ds. If we are evaluating, we should always take the inverse Fourier transform. So we'll take inverse Fourier transform. What is the definition?
It's equal to 1 upon
F
root
of
X.
x, correct, is equal to
1 upon root
1
2 pi.
upon root 2
root
pi.
2 pi, right?
Equation minus infinity to infinity.
From
Minus infinity to infinity,
F of s e raised to minus ix.
correct. F of s
D.
e raised to minus is x
D.
S.
ds. Right. So we have this with us, f of s. We can use it. Substitute the value. So f of x is equal to, so we are not now writing for s is equal to 0. We'll write in general. So minus infinity to infinity. What is the function? F of s. Check. This is your f of s. Root 2 by root pi. Root 2 by root pi sine ks upon s.
S.
Right. Into e raised to minus isx ds. Okay. Here it is 1 upon root 2 pi. Let me just write root 2 into root pi. So here I guess root 2 get cancelled. Root pi into root pi?
Pi.
Pi. Pi is constant and can come out of the integration. Minus infinity to infinity, the remaining thing is sine ks upon s into e raised to minus isx ds. Is it something asked? Check once. Sine ks upon s we can see, but there is no e raised to I, there is cos sx something. We have that sine ks upon s, but we have this. What you can do? We have the expansion or the formula e raised to I theta and e raised to minus I theta. What is e raised to I theta? In terms of cosine?
Cos theta plus I sin theta.
Right, cos theta plus I sin theta. And e raised to minus I theta is cos theta minus I sin theta. Please remember. So this is e raised to minus I theta. So what you can write for that? Baki everything as it is into e raised to minus I theta is cos theta minus I sin theta. Theta is sx. Theta is sx. ds. Now this will get multiplied with this and with this. Integration gets separate with the subtraction. So the next step will be 1 upon pi. Can you just tell me? F of x is equal to 1 upon pi integration minus infinity to infinity sine ks upon s into cos sx. Check once. This into this with respect to s ds. Then minus is there. Minus I 1 by pi is there, so I comes out minus I by pi. Only constants we can take out, so minus I by pi integration minus infinity to infinity, we are multiplying this term, so sine ks upon s is there and it is multiplied to sine sx into sine sx ds. Okay, now this is what we can see in our deduction or evaluate part. Means it is there, but this is not with the term. So how can you see that this value is getting 0? Let me give you one hint. As the integration limits are from minus to plus, what you can check?
Even odd.
Correct.
Even
And if it is odd,
0 directly.
value is directly 0. Correct. So as minus infinity to infinity, we should check. We are checking for the function s now. So this is the function of s. All are the functions of s. 3 functions are there. Okay. Sine is
odd.
odd. Very good. If you replace s by minus s, the sign of the function get changed. So it is odd. What about s? If we change the sign of s,
Odd.
s जर तुम्ही साइन चेंज केलं मायनस एस होतं म्हणजे याला निगेटिव्ह साइन येते. सो इट इज ऑड. सो डिवाइड असू देत और मल्टिप्लाइड असू देत, ऑड बाय ऑड or odd into odd is
Even.
right. And how is cos?
Even.
Cos is even. So even into even is
Even.
so the whole function is even here.
Yes.
Right. Same here. Sine is
Odd.
odd. Again sine is
Odd.
odd. Odd into odd.
Even.
Even. Then s is there. S is
Odd.
odd. Odd into odd or divide is also okay.
Odd.
Odd. So as the whole function is odd and integration of odd is
0.
so
0.
this is directly 0. And just check once whether they have asked you minus infinity to infinity or 0 to infinity for the first. Minus infinity to. So it's up to you that you want to apply that or you don't want to apply that. Right? We'll apply it here. We'll write the value 0 directly, and this is I'll write as it is. So therefore, f of x is equal to 1 by pi minus infinity to infinity sine ks cos sx upon s ds, and this is 0. So they have asked you this, means whatever the term multiplied, I'll shift here and I'll write the answer. Therefore, it is integration minus infinity to infinity. This term is equal to what? Pi into f of x. Just shift that pi. But we have f of x. What is f of x? Pi into f of x. This is your f of x. So let's just write it there. Pi into given function. So it is pi into 1 when mod x is less than k and 0 when mod x is greater than k. So therefore your answer is this pi is getting multiplied inside to the function, and therefore your answer is, wait, it is horizontal. Okay, so your final answer is like pi is multiplied inside pi into 1. So pi and pi into 0, 0. When mod x is less than k and when mod x is greater than k. So this is the answer for first. So the value of this is this. Is there any doubt?
No.
Okay, so the first deduction, first evaluate part is done. We'll go to second. Just think on the second if you have written. How we can obtain the second? Second is integration from 0 to infinity sine ks upon s ds. Yes.
Put x equal to 0.
Very good. You can see the sine ks upon s. Means this value is 1. But it depends on s, means we cannot change s. We can change x. So if you put x is 0, this becomes cos 0 and which is 1. Right. But there is one more change. Integration limits 0 to infinity are given. So what you can do now?
2 times.
2 times, as we know this is even. Right. So we'll just do the change. As this is even. Call it as equation number 1. This where we have written pi. This one, last one. Call it as 1. पुढे कुठे मागे 1 आहे का बघा? 1 दिलाय? Oh, दिलाय. 2 द्या. Now, as. So this can also be, 2 can also be like, as it is even function, it can be 2 times 0 to infinity sine ks cos sx upon s ds is pi when mod x is less than k and 0 when mod x is greater than k. And if you have asked this 0 to infinity, okay, if they can ask you that also, means what you will do? If it is asked integration 0 to infinity value of this sine ks cos sx upon s ds, what will be the answer? This 2 will just get divided to this side and it will be 1/2. And 1/2 into this, that is, what will be the answer? Right. Pi by 2 when mod x is less than k and 0 when mod x is greater than k. Is it clear to everyone?
Yes, ma'am.
Yes.
Right. So next is sine ks upon s, means we are writing x is equal to 0. So put x is 0 in this. Call it as third if you want. Put x is 0 in 3. So it is integration from 0 to infinity sine ks upon s. And this is cos 0, 1 ds is. Okay, there are two values. So which value you are going to choose? Please tell me. We are writing x is 0. So where is x 0? You have to first choose among these two intervals. In which interval x is 0 comes? Let me tell you, this is minus k to k. And this is greater than k. Like this is minus 1 to 1, minus 2 to 2, minus 3 to 3, like that. K is any constant. And this is x is greater than k. K can be anything. 1, 2, 3, 4. So if you want to choose x is 0, so x is 0 comes under this. Right?
Yes.
Yes.
Right. So x is 0 means minus 2 to 2 somewhere 0 comes. So x is 0 is here in this interval. So yes, if it is in this, so you are going to choose this value. Am I right? Yes. So what is your answer? Pi by 2. Pi by 2, if it is like cos x, if your answer is having pi by 2 into cos x, so you are choosing this interval where x is 0 comes, and then you are putting x is 0 here. So pi by 2 into cos 0, that will be pi by 2. But there is only pi by 2, no x term. So as it is, we are writing pi by 2. So yes, your answer is pi by 2. Everyone is getting. Is there any doubt?
No.
Good. So 2 deductions are done. Next, third one. What is the third? Integration 0 to infinity sine s upon s. What you can do?
Put k equal to 1.
Right. Put k is equal to 1, as k is again a constant. So put k is not the variable, k is constant there. So put k is 1. So we get. So this is your deduction number 2. And k is 1. So we get 0 to infinity sine s upon s ds. There is no k on this side. So value is pi by 2 again. This is third deduction. Done. All the values we got. This is the answer. And they can ask you the definitions, Fourier transform, formulae, inverse Fourier transform, and such things. They will give you this and they will ask you, what is this? What is this? So we have to write. And yes, if it is smaller, yes, it is smaller. You can check. If you have f of s with you, let me just show you. Okay, if you have this with you, they will give you and they will ask you f of x. You will have to just put it in the formula and you have to write pi into f of x. So accordingly, you can do if asked. Anything you want to ask? Go ahead. If no, chalo. Next question. Find the Fourier transform of. Find the Fourier transform of f of x is equal to 1 minus x square mod x is less equal 1 and 0 when mod x is greater than 1. Okay, this is the question and hence evaluate integration from 0 to infinity x cos x minus sin x upon x cube into cos x by 2 dx. Okay, the question is find the Fourier transform of the function f of x. means it is getting converted to S. And whenever the question is hence evaluated, it is of inverse Fourier transform. Means it should be with respect to S, but it is not. They just changed the variable finally S by X. Are you getting? Just to
Yes.
check the patience. That's it, nothing else. So if it is not in S also, you should understand that it is of inverse Fourier transform. The question is of inverse. Whenever hence evaluate comes, it is of inverse. And when you'll understand this, whenever you find f of s, that is Fourier transform, it can look like something, either this or any of the term. They will be similar. So you will get to know that this is of inverse Fourier. Chalo, start solving. First thing is you should go with the Fourier transform. So write first the Fourier transform. F of s 1 upon root 2 pi. Is this correct? Whatever I have written?
Yes.
No.
Minus
Yes.
infinity plus infinity.
Minus infinity to infinity. Correct. F of x into e raised to minus isx dx. Is this correct?
Sin
Whatever.
x plus. There
No,
should
it
be
is
zero.
plus. Right.
Positive.
It is plus. Correct. Chalo, put the values and solve. So 1 upon root 2 pi. Integration limits r. Go to the function and tell me the limits. Function f of x is defined on these two intervals. This is 0, so yes, gone. No need to write this. What is this interval?
Minus 1 to 1.
Right, minus 1 to 1. The limits of this function is defined on this. So limits are minus 1 to 1. And the function here is?
1 minus x.
Right, 1 minus x square into e raised to isx dx. Good. You have to solve the integration. Can you?
Yes.
How?
Leibniz rule.
Very good. We can apply Leibniz rule. Just think, can we apply Leibniz? There
Yes.
should be the function whose derivative will get 0 after some derivative. So is there such function?
Yes.
Yes.
1
Yes, this is the function. Whose first derivative is?
Minus 2x.
Right. Next is?
Minus 2.
And
minus 2.
next will be?
0.
Correct. So this is your u and this is your v. Start solving. 1 upon root 2 pi. Let me just take it forward. Minus 1 to 1. 1 minus x square e raised to isx dx. This is u, this is v. It is 1 upon root 2 pi. U
1 minus x square.
as it is, correct. U into v1, integration of this.
E raised to isx upon is.
E raised to isx upon
Is.
is
S.
or ix?
S.
S. Because it is with respect to
dx.
x म्हणजे s constant येईल and it will be s there. आणि इथे जर s असता तर
Ix.
Constant.
ix. Are you getting?
Yes.
Yes.
Yes. So it is x, but so as it is with respect to x, s is constant. So is. आणि पुढे हे करायचे आपल्याला. So take care of the variables. Then what is the sign there?
Minus.
Minus. Good. Derivative of this.
Minus 2x.
Minus of 2x. Correct. Integration of this.
E raised to isx upon I square is square.
Right. E raised to isx upon is, and one more is already there. So I into I, s into s, I square s square. Plus, minus, plus, derivative of this.
Minus 2.
DSY student, please pay the attention because the Leibniz rule everywhere we are doing it in Fourier series, and your only remained unit is Fourier series where we need to do this Leibniz rule. Please take care. Okay, u v1 minus u dash v2 plus derivative of this.
-2.
-2, correct. Integration of this.
E raised to ISX upon I cube S cube.
Correct. E raised to ISX upon IS, but already I square S square get multiplied I cube S cube. Then plus minus and derivative of this.
0.
0.
If it is getting 0, this is over. This is from -1 to 1. And you are writing the limits for which variable?
X.
X. So you are writing upper limit 1 over x. So 1 minus 1,
0.
0. 1 square, 1, 1 minus 1, 0, 0 into anything, this part is 0. Come here. Minus plus 2, okay. X is 1, e raised to is, x is 1 upon I square. What is I square?
-1.
-1 into s square. Plus minus 2, x is 1, e raised to is upon I cube is I square into I. But I square is -1. So -1 into I, minus I, s cube. Is it correct? Just check once.
Yes.
Okay. Upper limit is done. We'll go to lower limit. Lower limit, x we are writing -1. So -1 square plus
Plus
1. 1
1.
minus 1 again?
0.
0. Right. This is plus. X is -1. X is -1. So yes, plus minus. Can I write minus?
Yes.
Yes.
Already it is plus, but x we are writing -1. So it becomes -2 e raised to minus is, because x is -1, upon I square -1 into s square. Then it is -2 e raised to minus is upon I cube. I told you already, it is minus I into s cube. Yes, it is over. If anything wrong, please let me know. We'll correct it. If you are getting something different. Okay, so it is 1 upon √2 pi. This is minus, let me just collect, e raised to is, minus plus 2 e raised to is upon is cube, minus plus 2 e raised to minus is upon, no, minus plus, but outside is minus. So it is minus 1, 2, 3 upon s square, 1, 2, 3, again minus 2 e raised to minus is upon is cube. Right, these two I guess get cancelled. No, there is e raised to is, there is e raised to minus is. Now, this I is in denominator, we should try to take it up. What you can do?
Divide and multiply by.
Right, do it in next step or do it here only. Can I do it here? No, 1 upon √2 pi minus 2 by s square e raised to is plus 2 e raised to is. काय सांगता का जरा? is cube ना?
Yes.
पुढे
-2 e raised to minus is upon s square. -2 e raised to minus is upon is cube.
Okay. So here is I, so I'll multiply by I and divide by I. One more here is in denominator, so divide by I and multiply by I. Okay, so we get it here, 1 upon √2 pi minus 2 by s square e raised to is. Here it is I square, I into I square. I square is but
-1.
-1. So it is minus 2I e raised to is upon s cube. Then minus 2 by s square e raised to minus is. And here it is minus 2I e raised to minus is upon I square. I square is but -1. So this becomes plus upon s cube. Check once. Is everything okay? Arey yaar, we need I in the denominator for sign. It could be okay. Wait, we don't want to do this. Just wait. No need to do. No need to do. We can convert because see your evaluate part. Can you see cos and sine there instead E? Just check once. We need
Yes.
cos signs. So for sine there is upon 2I. So no need to do anything. Go here. Let that I there itself. Okay. So if you can check here e raised to is and e raised to minus is, common thing 2 upon s square. We'll take it out. Instead minus 2 upon s square. So it is 1 upon root 2 pi. 1 upon root 2 pi. What is that? Minus 2 upon s square is common. What is inside? E raised to is plus e raised to minus we have already taken out. So e raised to is plus e raised to minus is. त्याच्यासाठी your evaluation part you should always take care of. Always take a look काय विचारले. चलो next. What is common here? 2 upon, because we need e raised to I theta as positive. So we are taking 2 upon s cube out. I'm letting I in. Plus 2 upon s cube. What is there inside? E raised to is upon I. Check once. E raised to is upon I. And minus e raised to minus is upon I. Minus e raised to minus is upon I. Okay. Okay, there is plus. So what we'll need here for the formula?
2 divided
2.
by 2.
Right. We'll need 2. So we should multiply by 2 here. So I'll do it here upon 2. Or you can do it in next step. Okay. So minus 2 by s square. And for this formula, of course, we'll need upon 2. So divide by 2 and as divide, multiply by 2. Okay. So here it is 2 by s cube e raised to is minus e raised to minus is and upon I. Same denominator, so we can collect. But what we'll need here also?
2.
2I. As formula is having 2, so multiply and divide by 2. Okay, so we get here 1 upon root 2 pi minus 4 upon s square. What is this? E raised to I theta plus e raised to minus I theta upon 2. Cos theta. So it is cos s plus 4 upon s cube. This is what? E raised to I theta minus e raised to minus I theta upon 2I.
Sin s.
Sin s. Correct. So I think just check once. X cos x minus sin x upon x cube. Is it like that? Upon x cube means upon s cube. So here we need s cube. What you can do?
Divide and multiply by s.
Right. So we want s cube in the denominator. So just multiply by s to this term only and divide by s. So it is s cube. And this is as it is 4 by s cube sin s. Right. So it is 1 upon root 2 pi. Upon s cube is there now. Denominator for both of them is s cube. So it is combined. And in the numerator, what is there? Check here. Is it x cos x minus sin x we are getting? Yes, we are getting like that something. For that, what should we take out from the numerator?
4.
Instead -4. So it is s cos s minus sin s. We need this term x cos x minus sin x upon x cube. Are we getting now?
Yes.
Right. So yes, this is your Fourier transform. If you want to simplify, we can just -4 upon √2 pi s cos s minus sin s upon s cube. This is the required Fourier transform. Any doubt in this?
No.
Good. Sure. So we should now go to the evaluate part. Can we see the s cos s minus sin s? This term we can see only the just changes in variable. So we can change the variable finally. We know that. So we'll now check the inverse Fourier transform. You just note this f of s. Okay, so by inverse Fourier transform, what we get? F of x. The definition, 1 upon √2 pi minus infinity to infinity f of
F of s
s into e raised to,
minus isx ds.
very good, d
S.
s, right. So we have the f of s, we'll write it here. Tell me the value, please.
-4 by √2 pi
-4 by √2 pi
into s cos s
s cos s,
minus sin s
right?
upon s cube.
Good. So f of s we have written into e raised to minus isx ds. Do not hurry to change the variable s by x. It is after everything is over, the last step is only the change of variable. Before that, never do the replacements. Okay? So chalo, we are here and we have to go up to the deduction part. So deduction is, there we can see cos, not e. So what we can do first? This I can see, but I cannot see e, I can see cos. So we can apply the formula e raised to,
E
right?
raised to minus isx
Right.
equal
So here -4 will come out. √2 pi into √2 pi.
2 pi.
√2 pi is a square. Root and square get cancelled. It is just 2 pi. Come out of the integration. S cos s minus sin s upon s cube into, this is cos sx minus I sin sx ds is f of x. But here 2, this is -2 by pi. -2 by pi into minus infinity to infinity, this into this into this. Just do that. S cos s minus sin s upon s cube into cos sx ds minus again 2 by pi, and there is minus I, so minus plus I can come out this term s cos s minus sin s upon s cube into sin sx ds is equal to f of x. Now we should check the function. We'll check this. If we replace s by minus s, what will happen? So minus s cos minus s minus sin minus s. Numerator. So cos of minus s is cos s. And sin of minus s is minus sin s. So minus become plus sin s. So here I can take negative sign out. So s cos s minus sin s. S cos s minus sin s, but there comes negative sign. Means how is the numerator? Function, if we replace all the values, all the signs of that s, your function get negative value. Means how is function? Even odd? If f of minus s is minus of f of s, how it is?
Odd.
Odd. So this is odd, right? And s cube is s ला minus s ठेवून बघा.
Odd.
Odd. Odd, odd,
Even.
even. And cos is
Even.
even. Even.
Even.
Even. So this is even, so it remains. Okay, we have checked this. This is odd. This is odd. This is odd. Odd, odd, even. And sign is
Odd.
odd. Even, odd,
Odd.
odd. So this is odd, means its value is 0. Directly it is 0, right? It will remain. So it is, I think, evaluate is 0 to infinity. Check. Yes, it is 0 to infinity. So this is even, so I can write it 2 times 0 to infinity. That is
Yes.
f of x is equal to minus 2 by pi, 2 times 0 to infinity, s cos s minus sin s upon s cube, s cos s minus sin s upon s cube into cos sx, right? Cos sx ds. Cos sx ds. Okay, so we are there, right? Just check it. 0 to infinity. If that x is suppose s cos s minus sin s upon s cube into cos s by 2 should be there, right? Check. It is x by 2. If suppose this x is s, so this should be also s by 2. So it should be here s by 2. Means what should be the substitution? Bola?
2 x equal to s by 2.
S is already there. We need cos s by 2.
1 by 2.
1 by 2, right? So put x is half. So it is f of half everywhere. Minus 4 by pi. Integration 0 to infinity. S cos s minus sin s upon s cube into cos x is half. So it is s by 2 ds. Check it here. But before that, what is f of half? We need f of half. This is function f of x. Where will be the half? X is equal to 1 half. Will be in this or this? Minus 1 to 1 मध्ये half येईल का इथे half येईल?
Minus 1 to 1.
Right. So x is half is here. So x is half. The corresponding function is this. In that we can write x is half and solve. 1 minus 1 half square. 1 minus 1 by 4. 4 minus 1.
3 by 4.
3 by 4. So what is f of half? 3
3
by.
by.
But f of half is 3 by 4. So substitute here. So 3 by 4, take it here, left side, minus pi by 4 is this. Integration 0 to infinity as it is. Cos s by 2 ds. Now this is what we need, but there is now change of variable because they have asked you in x. So now can I change the variable?
Yes.
Yes. So this is minus 3 pi by 16 is integration 0 to infinity x cos x minus sin x upon x cube into cos x by 2 dx. The change we can only do in the last step. This is your required solution. So evaluate this solution of this integration is minus 3 pi by 60. The answer. Is there anything you want to ask? If no, please wait. Let me take attendance. Do not leave. If you have anything in between, you can ask. But wait. So all of you now know that such questions cannot be in online exam. So what you should remember, you know, all the formulae and the smallest part आहे त्यातला, you should always remember them. Okay, it's done by my end. If you have any question, Ata left. Huh? Any problem? Ma'am, B50 is a network problem आहे. Okay. Who is B50? Okay, I'll put the attendance. Don't worry. B50. Chalo. Can we stop? Bye bye.